Hello there and welcome to this course on Python Fundamentals for Finance. My name is Valentine and I'll be your instructor. In this course, we're going to follow this structure. So we'll get started with the learning outcomes. After that, we'll get to learn about Python fundamental concepts that are important when it comes to working on finance projects. We'll also get to cover a bit of why one would want to undertake this journey. After that, we'll go to into our practice session, and this should take us about an hour or so. And in this particular part of this course, we will practically apply the concepts that we will have highlighted that pertain to Python fundamentals for finance. We'll also provide challenges so that you can be able to practice and acquire the skills that you are looking towards acquiring in this workshop. So let's get started. By the end of this workshop or course, you're expected to have achieved these learning outcomes. So you should be able to explain the importance of learning Python fundamentals for finance. You should be able to demonstrate proficiency in Python syntax. So knowing how to just generally write Python code. You should also be able to identify and use different data types and variables in Python, such as lists, tuples, dictionaries, and sets. These are just containers that we use to temporarily store data that we can later onwards perform some operations or manipulation on. You should also be able to implement control structures and loops in Python. These might include using what are called if-else statements, or being able to use what are called loops, or for loops and while loops, which provide us with a way to iterate through or to go through a collection of items. And lastly, we should be able to create and use functions and modules in Python, which is just generally a way of organizing code that we have written in Python for efficiency purposes. So those are the learning objectives. By the end of this learning experience, you should be in a position to say that you have acquired those skills. Starting off, Python fundamentals generally for finance means we're talking about those foundational concepts in Python programming that would be relevant in the field of finance. So these might include the concepts of variables, data types, printing, comments, arithmetic operators, F strings, if statements, loops, dictionaries, lists, functions, and modules. These are basic Python concepts that we would normally undertake when it comes to just learning about Python. And you would, in some contexts, find these same concepts in also other languages or in other programming languages, but now implemented in a different way. Programming languages are just those tools that we use to create software that perform specific tasks. So we can classify Python as one of many programming languages out there. There are many programming languages suited for different purposes. Python is suited for generally data analysis work, web development work, for creating desktop applications. You could look or you might hear of other languages such as Java, which are much more suitable for either web applications or desktop applications. So Python will be our focus for this particular workshop, and the idea is that you will have acquired these foundational skills enough to enable you to undertake any sort of work related to maybe data analysis work in finance, or maybe web development work still in relation to finance. Why would you want to learn Python fundamentals as a finance person? So one of the things is that you would be in a position to analyze financial market data efficiently using Python. So the beauty about Python is that it allows you to efficiently process large volumes of financial data. And as a result, you're able to identify trends and patterns and even anomalies within the data that you're working with. as opposed to other tools that may not necessarily provide those functionalities to perform in-depth analysis out of the box. So you might find it hard, for instance, to detect anomalies in maybe a data set. And Python allows you to be able to detect those anomalies with ease, and get to the outcome that you want to get to, which could be maybe to identify outliers or even to just identify trends. You would also be in a position to develop and also deploy algorithmic trading strategies if you get to learn more about Python, and also if you also want to maybe focus on learning more about trading algorithms. So there are powerful libraries in Python, and libraries are just chunks of code that have been created by other stakeholders within the same field. So in Python, you might find other chunks of code, which we tend to call as libraries. So you might find libraries such as QuantLib, such as PyAlgoTrade, which would allow us to be able to create trading models or algorithms that would allow us to be able to automate maybe trading systems or so. You might also be able to do some sort of portfolio optimization efficiently and also asset allocation efficiently if you use Python. Python provides tools such as or libraries such as SciPy that allows us to be able to optimize investment portfolios based maybe on diversification or even just some set of constraints that we might have, and you would end up as a result being able to construct portfolios that maximize returns while again minimizing risk, as an example. There's being able to conduct financial modeling and also forecasting. There are other libraries, there are specific libraries aside for the ones that we've talked about, such as there's one that's called Stats Models, and even Prophet, that allows us to be able to create financial models and also be able to perform time series forecasting. So work with data that has been collected over a time period of time and be able to use that data to make predictions about specific aspects of our research that we would want to address. So maybe whether it's maybe predicting future maybe stock prices, or maybe estimating company valuations, or even just forecasting some macroeconomic indicators, you can be able to use Python to be able to accurately create those models, or which are just generally programs that learn from historical data and that are able to help you in that financial decision making that you are undertaking, that process of financial decision making. Lastly, you might also end up being able to analyze customer transactional data, maybe for fraud detection or compliance. And this might be in the case where you maybe work in a bank or you work in an institution that provides maybe financial incentives, or it provides financial products to customers. Then in such situations, you can use Python to be able to detect those fraudulent activities that might be happening, or even just identify suspicious patterns, and be able to later onwards make recommendations that would allow for that not to happen within your organization. These are just a few reasons why we would want to use, we would want to learn about Python, so that we can be able to address some problems that touch on these different areas. There are many other reasons that you could learn Python for in relation to finance, but these are just some of the popular reasons that should give you just a good idea of why you should undertake this journey. When it comes to different roles or experts in the finance sector that would find Python important, these are just a few. So there's financial data analysts that would most likely work with finance data. It could be that they might be working with data in relation maybe to, I don't know, economic indicators, or data in relation to stocks. Their tasks would involve being able to import that data, like collect that data from just different data sources, whether it's just different APIs or even databases, clean that data, analyze it, and then be able to visualize it and create presentations or reports that other stakeholders might find useful. Risk managers, on the other hand, would use Python to build risk models that assess market risk, that assess credit risk, liquidity risk, different kinds of risks within financial institutions. And the idea here again is to be able to identify those risks and also be able to mitigate them. And in such scenarios, risk managers would find Python beneficial. Portfolio managers, on the other hand, would use Python possibly for just portfolio optimization or rebalancing, with just the aim of just ensuring that they're able to maximize returns and at the same time be able to minimize risk. Financial software developers would be, just as the name says, software developers who work within financial institutions, and these stakeholders or experts would develop software applications. It could be web applications or what are called APIs, which are just applications that allow you to interact with a particular service. So financial software developers might use Python to develop those software applications that are critical for financial institutions, and as a result be able to provide a product that customers might love. And software developers are usually also they're usually almost everywhere within financial institutions, because a lot of products that financial institutions offer usually come in the form of software products. Financial research analysts on that other side would be those professionals that just do empirical research, maybe statistical analysis, and even do a bit of some machine learning. And their job will be just generally to test maybe hypotheses or even just develop predictive models. Lastly, financial consultants would also use Python to perform data analysis or machine learning, or even just do scenario planning to be able to help organizations go about research problems that they might be having, which might include possibly investment decisions, risk management decisions, or even just financial planning. So those are just a few roles in terms of deliverables. These are just a few deliverables that one would end up working on if they are to use Python. So being able to create mathematical models, being able to clean and organize data sets, create data analysis reports and visualizations, create risk models, portfolio performance reports, financial software applications, as well as client presentations, which are more reflective of the roles that we have already talked about. So yeah, so that's just it in terms of just the what and why, to get you to have acquired some foundational Python knowledge or theoretical knowledge that will come in handy when it comes now to just working with Python generally. It doesn't make sense for you to start working towards learning Python if you don't really know why exactly are you learning Python, and also if you actually don't know really the roadmap itself, because at some point if you learn a technical subject or like Python, video description section, so it's a resource link, just click on that link and it should take you to our website. So once you click that link, it should take you to this particular page that you see, that will provide you with a sample practice resource that we are going to be using for our workshop today. Once you have gotten here, just click sample practice resource, and that should take you to what you're going to be seeing on your screen, to this particular document that will contain content that we have already curated in relation to Python fundamentals for finance. And so we have organized this notebook in form of examples, explanations, as well as provided challenges that you can undertake. You might also notice we are calling it a sample. The reason is because this is content that we are providing to the community. Anyone can use in the practice notebook for those who are going to be afterwork members or already are afterwork members. The difference is that for the sample notebook or that we've curated, we've only provided challenges for half of the content so that you're able to follow through. But if you want to be more committed, as you can see here, you can see there's challenge 1, there's another challenge, there's another challenge. But for these other sections, this is just a table of contents. We don't have challenges. But we have done that in the practice notebook. We've provided challenges throughout that you can be able to work on, and also provided a solution notebook that would allow you to just verify content, to verify the solutions to the challenges that you'd want. So that is just part of becoming an Afterwork member. You get access to that content, and you get also access to all the content that we've ever produced in the past, including projects that you can use. If you're not sure about Python yet, there are other Python fundamental courses that we've done. You could always try them out, whether it's in banking, whether it's in healthcare, whether it's in manufacturing. So there, all that resource, you'll together with the solutions and full practice work, you'll get to have access to that again once you've become an Afterwork member. But if you're not really interested so much with that, let's hop into our practice work and sample notebook, and then we can get started. So what you're seeing is a notebook, which is just a document that allows working professionals, or such as data scientists, to share work. A notebook normally would be that document that has sections where you can be able to execute code. Like you can see the grayed out section over here. It contains code. This is code that we can be able to run. And these are the sections over here, which we call cells, are not executable. You just put in content, and you can contain content inside content. So for this particular scenario, we're going to, the first thing that we're going to do once we have gotten to this page, we need to save this notebook as a copy so that you can save it to your Google Drive and be able to access it later onwards. So click on File, then save a copy in Drive to save this notebook. Once you have done that, just click on this, save a copy in Drive. It should open a new tab, and then you can use that copy and close now this original one. For me, I'm just going to say open in playground mode because I am not going to save any changes. I already have the notebook. Yeah, so that's just about how you just quickly get started. By the way, if you have any questions, feel free to ask in the chat section. And if you feel like I am too fast, you could always pause the video, rewind it a bit. That's the beauty about streaming. And you can just rewatch again and again. And don't worry if we are too fast. It's because everyone has just different learning abilities. There are people who are fast. There are people who you have to take them slow. So hopefully that also just feature of just sorts it out. So all right, starting off, we're going to connect our notebook. Let's connect this notebook to Google servers. This notebook is hosted on Google Drive, and we can be able to connect to Google servers to be able to run the code in the notebook. So let's do that by clicking on Connect on the top right. Click on Connect. Now just make my screen a bit bigger. So it's going to say connecting. All right, once it has connected, you should see this green check and you should be good to go. The first thing that we're going to be learning about are variables and data types. So variables in Python are just containers that we use to store some value or some piece of text, some piece of data that we can later onwards perform some operation on. Maybe you might decide to store a table inside a variable and then perform some operations like visualize the first 5 records of that table. You're going to be referencing now that container. So a variable is just a container that you use to store data temporarily, and then later onwards apply some operations to. So variables also store data in different forms. Data usually comes in different forms. There is data that comes in text, data that comes in numbers, etc. But in Python, data can come in the form of numbers, and more specifically, we tend to say whole numbers are of an integer data type. So data can come in the form of an integer data type, like here we have 10, which is an integer data type, or if decimal point, so 3.14 is it's a decimal, but in Python we just call it a double data type. So integer data type, double data type. For piece of text, we enclose the piece of text in quotes. It could be double or single quotes. If you don't enclose it, you'll get an error. So you have to enclose whatever that you want to be considered as text in double quotes. You have the opening quote and the closing quote on the other side. And we store, we can store now, we refer to that data type as string. And there's another data type that we normally use called Boolean. Boolean can only hold 2 values. There's true or false. So it's either true or false. The idea is just sometimes you might have some piece of text that you want to store efficiently, but instead of storing maybe a value true, as a string, instead of doing that, you just store it as a Boolean data type, because you can either have true or false in terms of that piece of data. So that actually behind the scenes ensures that the computer doesn't spend a lot of memory when it comes to storing that value, because our data here, once we have created a variable, we are actually behind the scenes telling our computer to allocate memory locations, like to set aside some space so that it can be able to store that data. So for us, in our case, we have 4 variables. And when we are creating a variable, we usually give it a name on the left-hand side. And then we give it a value by using the equal sign. And the value that we want to give it is usually on the right-hand side. So for the first example, we have the variable int var, and we are assigning it the value 10. So we usually say we are assigning the value 10 to the variable int var. We are assigning the variable 3.14 to the variable float var. And the names, as you can see here, usually there are conventions or rules that you can use, but it's good practice to just start with variables that have lowercase characters as shown here. And if there are multiple words, you can separate them with an underscore. So once we have created our variables, we can display them. So once you create a variable, if you want to see what's inside those variables, you can display it. And to display it, we normally use what is called a print statement or a print function. And a function is just a chunk of code that performs a specific task. But for our case, we're using a function that's called a print. It's a print function, so it prints out values. So in our case, we are printing out int var, float var, str var, and bool var. So the print function usually comes like that, but you have to give it something. You have to give a function an input, then it's going to give you an output. But sometimes you may not give you an output, depending on how you have designed the function or how the function has been designed. But for our case, a print function expects an input or multiple inputs that will later onwards be printed. So in our case, we are telling this function print int var, and the input usually comes in now these parentheses that we see here. I have 2 parentheses here, so I need to remove one so that I I don't have to. Sometimes I might fix this in the notebook. You might not find it, but this is how you should now be able to have that. So if we run this code, by the way, if you get this pop-up, just know that you did not save a copy in Drive, and you won't have any changes. So you need to save a copy in Drive and then connect. But I don't need to. I'll just run anyway. If I run this, below this code cell, I should be able to see now my output. So the first print statement, which is this one, printed out 10, which is the value of int var, then the value of float var, the value of hello world, and the value of str var, the value of boot var. If you wanted to also determine the data type, I've talked about the data types, but if you wanted to determine those data types, you can use what is called a type function. So here we are printing out the variable itself, but we can also have another function called type. Just typing the name type, and then in the parentheses, so we give, let's say, the type function int var, the variable, and it's going to give us the variable, the data type, and then we print out the data type using the print function. So it's like we are nesting a function inside the function. So generally what we are going to get here is the data type for 10, then we're going to print out the rest. So the data type for 10 should be int. So if I run that, I should be able to see class int. This is the data type that we want. You could do the same thing for the rest to just determine the data type. So let's say for type, so the second one, float var, if I run this, I should get a float. So you also have data types. You also have data types, which is called a float. Float is actually a decimal number. This is double. So float, actually use float, don't use double. So there's float that we can also be able to use, which is just decimal type, decimal generally. There's also, you can do the same thing for type. Let's just do that there. For the string, you should be able to get str, and also you can do that for Boolean as well. All right, there's this challenge. Create a variable called balance, assign it value 1000, then create another variable as well and assign it this value and print out both variables. You'll just use the same concept that we have learned here to be able to do that. So we are not using the type function here, we're just printing them out. So let's do that, and once we have done that, we should be good to go. So you can pause the video so that you don't quickly realize that we're moving too fast. Just pause the video, and then once you're good to go, we can continue. And if you're an Afterwork member, you can verify the solution to this particular challenge by going to the solution notebook that we have shared above. Okay, moving on, printing and comments. So I've already shown you how we can be able to print out using the print function, but we can also be able to print out a variable plus some other data. So I mentioned to you, you can give multiple inputs to a print function. So this is our print function. This is the variable that we've created. So we can give it to, give the print function this string, and then put a comma, then give it another piece of information, put a comma, and then give it another piece of information, etc. And it will just generally print what we have. And whatever that you'll see here that's highlighted in green but has a hash in front is treated as a comment. And a comment allows us to provide just explanations, to what this code is about. And it helps because sometimes we might forget, we might write code, then 1 year later we look at it and we're like, what did we write here? And comments just help explain that. And also it helps also others be able to understand your code if you're going to be sharing it with others. We provided explanations as well as an explanation over here for what the concept entails. Work on this challenge, and then once you're done, we can continue. All right, moving on, F-strings. F-strings allow us to be able to embed like variables inside the strings that we want to print. So, and those those variables within f strings, we call them expressions. So for example, if we wanted to print out stock name, then even just have the variable name inside in the middle of stock and name, we can use what this approach to be able to do that instead of having multiple inputs, like, you know, string, then variable name, string, variable name. This just provides us an easier way. So we use the print statement, then we use the f character, then in quotes we put some quotes, then we define this the string name, so stock name, the string, not the name, just the string. Then we define the variable where we want the variable to appear inside our string by using curly braces, as you can see here, stock name. We ensure that we haven't closed those curly braces, and that should be it. The same case with stock price, as well as number of shares. So just note that the beauty about this, you can just put in your variables inside the string where you want. So if I print this, I should get stock name, AAPL, and it also takes account of this space that we have here, etc. Yeah. All right, work on the challenge, and once you're done, you can continue. You can pause the video. Moving on, sometimes you might want to perform maybe basic arithmetic operations. So if you want to multiply maybe the value of one variable and another, then we can use either in addition, subtraction, multiplication, and division operations. And yeah, so let's first of all create the variables that we want to use, which are these ones, and we can use those variables to calculate the future value. If, of course, we know the formula, which is initial investment times, which is a star, then into parentheses, or into brackets, 1 plus annual rate, which is what we have here, and then to the power of, let's say, years. To the power, we usually use 2 stars to define that operation. So yeah, so, and then we print out our future value, which is what we have here using just the print statement. All right, work on this challenge, and once you're done, then we'll continue. You can pause the video. String manipulation. When we are working with textual data, we might want to perform just different operations. Maybe you might want to maybe uppercase all the characters, or lowercase all the characters, or put the text that we are working into sentence case. We can, there are various ways that we can be able to do that, and maybe, and the goal for that would just be able to just ensure that our data is ready for maybe further analysis later. So you don't want to have capital and lowercase letters or lowercase words all together. You might want them to be in the same format. To be able to do that, we usually use the upper function. So we apply, say, the upper function at the end of, let's say, the variable that we are working with. So stock symbol, and then we apply, we created this variable, then we apply this function, uppercase. We store the outcome of this operation inside this new variable and print it out. And we should be able to see that we have APPL, but we can also do maybe AAPL to see the change that transpires, which you can see, or even ADPL. You can just play around with that as well. All right, work on the challenge, and once you're done, you can continue. Just pause the video. Data type conversion. So we've talked about these data types, which are just generally classifications that we assign to data. And we've talked about different of them. And sometimes you might want to convert maybe an integer into a float, or a float into an integer, or even just a string or a float into a string, so that you can put it in a string. So that you can combine maybe that integer with other strings, because you cannot be able to combine easily an integer plus a string. But you can with an integer plus an integer, you can, an integer plus a float, you can, a float plus an integer, you can, but you cannot be able to do an integer plus a string. So you might want to convert one of them, which would work. And to convert, we use, again, functions. Functions will come in quite handy. So like, for example, if we wanted to convert a string, which is 500, to an integer, which will actually end up being just 500 as an integer, we use the int function. So we give it this input, which is expense str, and store the outcome in expense int, and we preview that total expenses. And then we can convert also float to a string. So this is the float that we have. We convert it to a string, and we store the outcome here, and we can print out that. So we should be able to, and you can see here we are now combining a float with a string, but now joining, we're joining this particular the method that we're doing here. It's like combining. We're using a plus here, but here we're using a comma. So here we are joining. In Python, we say we are concatenating when it comes to joining something. We are concatenating. We don't use we are combining. Oh, yes, you can say that, or we are joining, but we usually use a programming language. We say we concatenate. So we can decide to concatenate by using just the plus and have that. So we are combining this string and this other string. And in our case here, we are also printing out this string and also this other string. Yeah, so let's do that. Let's run that. All right, work on the challenge on data type conversion. And when you're done, we can move on to the next step. All right, the second section, data types and variables. We've already talked majorly about data types and variables, but we'll just touch onto them just a bit more so that we're a bit more comfortable, and also introduce a few other data types. So starting off, we'll get to learn about numerical data types, which we have, the integers and also floats. And we can be able to do just mathematical operations, with those particular values, like say, for example, addition or multiplication. And yeah, so this is just a quick recap of what we have done. So run that to be able to see the outcome of what we have here. So we have 13.14, which is the result of this code. The same case with 31.40, which comes after that code. All right, work on this challenge, and when you're done, you can continue. You can pause the video, and then you can continue. All right, Boolean data type. It's that data type that we had mentioned that usually represents that concept of true or false. So you can store either true or false values. So for example, in our case over here, we might want to determine, let's say, for example, stock price. These are two variables we've created. If stock price is less than target price, which we do here, we determine that by stock price less than target price, which will give us a Boolean value. So this is just an expression, but we will get either true or false. Stock price less than target price it is, so we should get true as our outcome. Work on the challenge, and yes, pause the video, work on the challenge, and once you're done, you can continue. And if again you're an Afterwork member, remember to verify your solution. Lists, tuples in Python. So we so far have been using just generally variables, and variables have been able to store just one piece of data. So with variables, we can store just one piece of information, whether it's an integer, float, or a string. But if you want to store multiple pieces of information together, maybe fruits, maybe just wanted to have a variable called fruits and wanted to store pieces of information such as bananas, oranges, pineapples in the same variable, then we can use what are called either lists or tuples. And how even the others are called sets that we're going to also to learn. We can also do the same thing, but the most straightforward way is just to store maybe lists, like lists, use a list. So a list is that particular data type, but in Python, we tend to call them data structures. They're still temporary containers that we can use to store data. And a list, for example, stores multiple items. So for example, if you have stock prices, we have 100, 105, 110. If we wanted to store that piece of information in a list, we first of all, on the right-hand side, define a square bracket, left square bracket and a right square bracket. Then inside those two square brackets, we define the items or the pieces of information that we want to, store together. So we define the first item or the first piece of data, then separate it with the next item using a comma, and do the same case for the other items. And what will happen here is that we will store this list inside stock prices, and we can be able to retrieve specific items from the list, or even just print out the entire list, or delete or add items to a list. So that's the beauty about a list. A list allows you to be able to even modify, play around. But if we want to still do the same thing, by the way, we can also do with commas, strings. You can also store string information, or even just generally Boolean information, true or false, inside a list. But if you wanted to be able to store those pieces of information, or that piece of data, or multiple pieces of data, but not want to modify it later, we tend to use what is called a tuple or tuple. And the difference between a tuple and the list is that you are using a square bracket to enclose the items that you're working with when it comes to a list. But when it comes to a tuple, you're using a parenthesis, as you can see here. And for parentheses, again, for the tuple, you cannot be able to update elements, but for a list, you can update. So there are constraints with a tuple. And there's these two keywords that are mentioned often. There's the word mutable. Mutable means you can be able to modify the elements, but immutable, which means you cannot be able to modify the elements, is what a tuple is. A tuple is immutable. You cannot be able to change the elements in the list. To retrieve items in the list, we usually use, for either tuples or lists, we use what are called indices. So for example, if we want to retrieve the first element here, we normally have, the element usually in a list or a tuple is given a position. So this is usually position 0. The same case with this one. Then we start from position 1, 2, 3, 4. So the positions within a list and a tuple or in Python usually start from 0. So this starts from 0, the same case here. So if to reference maybe the third item here, let's say this item, we would need now to use this position. So we say 0, 1, 2. So we can say stock prices, and then we put square brackets, then you use the position 0, 1, 2, because this is going to be representative of the third item. So we can be able to print out the stock prices shown. So we just pass this particular piece of information to the print function or input, and we are going to get the same case. And you can play around and see what happens if you give, let's say, an index, or position. The positions, we normally call them an index. We can give it a position that does not exist here, and you can see what's going to happen. We'll most likely get an error. And aside from this, you can also do further operations. Maybe if you wanted to get maybe the first element and the second element, you could even do, let's say you wanted to get 0 from one particular element to the other element. So you do 0 to 2, let's say 0 to 2. This is double colon. 0 to 2, which should mean 100 and 105, etc. But you can just play around with those indices and see what you would get. All right. Now you might see, if you're going through the sample notebook, that we haven't provided the challenges. The challenges again are over for people who are not members, but you can still consider becoming an Afterwork member. And you get all the challenges that you need for practice. But if you are an Afterwork member, you can continue practicing with the practice notebook, which has a challenge, and you can pause the video. Moving on to dictionaries and sets. These are an upgrade of lists and tuples, in that they provide an extra dimension. So for example, we have this variable stock prices, but we can store, let's say, this AAPL and its respective value. So a dictionary allows us to store collections or pieces of information in a key and value format. So you have a key, which is what you see on the left-hand side, and a value format, the value on the right-hand side. It could also be maybe you wanted to store maybe, a dictionary called maybe car. You could have model, then the model value. Let's say you could have another property pertaining to, let's say, a car. But this, you can think of them as a property and a property value for the respective context or entity that you're working towards. So this is a dictionary. There's also another data structure. We've talked about lists, tuples, dictionary, which allow you to store data in key and value format. But you can also use sets. Sets allow you to be able to to store data in an ordered way. So, for example, we could have Google or Amazon. You could have whatever information, but the positions that you have here, it's usually behind the scenes. This is given 1 as a key, and the value is Google, Amazon as a key, and 2 as a key, and etc. So generally, that's the difference between a dictionary. But most of the times, we normally use lists and dictionaries. Tuples, not that much. Sets, not that much as well. And this is how you're able to print out the dictionaries. So we would use this other concept, which we'll get to go through in a few. But I thought, why not introduce this concept? You can print out, use the print function and just say print, say stock prices, and it's going to print out the entire dictionary. But you might want maybe to retrieve all the elements individually and print them out individually instead of printing them at once. We use what is called a for loop that allows us to iterate through a collection, and you can also use it with sets and lists. So the for loop allows us to iterate through each and every key value inside our dictionary. The same case inside our set. So for for loop, you would define the current item that you want to the names of the current item that you want to iterate. So in the first, let's say, iteration, we would have APL equal to stock, and this value 150 equal to price, and then we can print out those values. So for loop usually has a body, which is defined by this indent. An indent, it's just a tab on your keyboard, so just space, but double tab, or you can just even single tab, it's okay. But whatever that comes in that section is usually treated as a body, and it can be multiple. You can have multiple lines within the body, which will be defined by it having just a tab from the for keyword. And yes, so stock price in, let's say, the first iteration would be APL 150, and we print out stock, which is the variable, and the price. Then once we are done with that, we go to the next one, Google 2500, etc. In just defines whatever that we want to iterate through. So it's stock prices, and we define that the items, it's items, that's what we want to iterate through. We do the same here, but now here we are not going to reference items for the set. We're just going to just reference the set itself and be able to print it out. And this method actually is what we can also use for, assuming this was a list or a tuple, that's what could have done as well. So let's run that. We should be able to see the stock prices, which are these ones, and also this statement, top performing stocks, as well as Amazon and Google. All right, you can pause the video, work on the challenge, and then we can continue. Control structures and loops. So sometimes you might want to determine whether a value or a variable is equal to another variable, and we can use an if statement for that. These are quite handy. They make us be able to make decisions in our code based on maybe certain conditions. So for example, if the stock price is less than buy price, which we have here, which is an expression here. So this, we have to define our expression. If this is less than buy price, and we put a semicolon which to define the end of our expression. Then we want to execute what's in the body of this if statement. This is like more like a for loop, like whatever that comes not on the same level but inside. So it's like double tab. So we have two tabs here. So you have to ensure that you have two tabs in such a situations, or even just one would work. But this will be executed if this particular expression turns out to be true. If it turns out to be false, it then will be the else keyword over here would actually handle that particular situation, and this would be executed instead. So let's run that. Tells us hold or sell stocks because stock price is greater than buy price. You can, these operators over here, it's less than, you can work with greater than, you can work with greater than or equal to, or less than or equal to, or, you know, less than or equal to. You can also work with equal to, which is usually double. You can also work with not equal to, which is as shown. So put an exclamation mark and etc. So let me just go back to that. Work on the challenge and then we can continue. Nested if, so this is more like an if statement inside an if statement. So here we have these two variables, and then inside the body of the first if statement, we can also put another if statement to further check for another multiple condition based on the fact that this was true. This just allows for us to be able to check for multiple conditions, especially in complex cases. So let's run that. Work on the challenge, and once you're done, we can continue. Else if statements. So else if statements allow us to check multiple conditions, maybe in a structured way. So assuming that we had, this is an if statement. So assuming that we wanted to also check at this level. So we wanted another if statement somewhere here, another expression to be taken care of here. So instead of just directly going, let me just go back. Instead of directly going to the else here, we can put an elif statement that allows us again to check multiple conditions in a structured way, instead of even just going in a nested approach as we had seen here. So we can use an elif, and then we put a condition. This is our first condition. We want to check this condition. And also, we want also to check this other condition. Both have to turn out to be true in order for this statement to run. If both are not true, then you'll move on to else. If you just want to check one, either if this one is true only, you can always use or is the other keyword that you can use. And if this is false, it will also check this other one to check if it's true. If it's true, then this will run. So let's run that. All right, and now work on the challenges, the challenge we have shared. So in the practice work, you should find the challenge. For loops in Python allow us to iterate over a sequence of elements. So I had already demonstrated this earlier when we were working with dictionaries. So for loops, this is what we had used earlier. So with for loops, we can be able to iterate through not only a dictionary, but even a list. So for example, assuming we created a list and a variable, this is our list, and we want to go through this list. But then this total value is just a variable that we want to initiate, like have a value for it initially and use it inside our for loop. This expression, as you see here, you can rewrite it as something like this: total value. So this expression here, you can write it in an easier way. That's why programmers or people who write code tend to be efficient, so they can rewrite it. You can rewrite it as this. So this expression, this one over here, you can rewrite it as this. Let me put a comment. Whatever that will come after the hash will be a comment. So this expression is the same as what you see here. And this operator, it's an operator, we call it an increment operator. And it's based off the idea that you're adding the total value to another value. But you can also have a minus so that it becomes, let's say, a decrement operator. So those two expressions are also the same. And that's what's actually happening there. So technically, what we are doing is we are going through each and every element or item. A list can hold elements or items. You can use whatever term. And we are going through the list and doing this operation, total value. And at the very end, you'll get to see that the total value is actually the sum of everything that you have here. You print that out. While loops are more like lists, only that you have a condition. So you have balance, let's say less than 2,000. So you have this condition. So while balance is this, then inside the while loop, you do an expression, then you do some operation. Then this is again, years is equals to years plus 1. So now it will go to 2. So years initially has 0. So in the first iteration, at the very end, you'll have 1. The value of 1 will be just, the value of year will be 1. Then you iterate again. Then the value of year will be true as long as balance is less than 2,000. And the balance value always increases. But this is just, it allows us to be able to repeatedly execute a block of code as long as there's a specified condition. So run that, and if you haven't understood, just go through the explanation, and then voila. So I'll actually go through just this example and another function example, and I'll leave it for you to continue working on that. So for when it comes to also working with, let's say if you want to stop somewhere during your iteration, you can stop by using a break statement. So a break statement allows us to stop completely our iteration during our for loop or while loop, and stop at that. Sometimes you might want to stop iterating at 105, then we can use a break statement. And of course, you'd have to ensure that the logic that you've created is okay. Or you can use a continue statement to stop the current iteration and continue in the next iteration. So whatever that will come after this continue statement, if this turns out to be true, won't be executed during this iteration. Instead, we'll continue to the next one. All right, work on the challenge. So the last thing that we're going to cover before we close is functions, and I'll cover this really fast. Functions allow us to be able to contain a block of chill code and be able to execute it later onwards. So for example, we can create a function that writes some code that calculates a compound interest, and that function, we would give it some input, which is principal, rate, and time. And inside that function, we can have that operation that we want and return the interest. So it's like what we are doing here with other functions. We are, print function, we're giving it an input and it's giving us an output, but here we want a custom function that will perform our operation. That's how you create a function, but you can then call it, as you can see in this example here, we have calculate stock price, we're giving it stock value, we're giving this 2 values, and then we can be able to perform this operation. It gives us total value. Then we define 2 variables, and then which will be our input to the function. So we're calling a function, giving it an input, and then we print out its value. All right, I won't go further. I'll let you to work on the rest of the content by yourself. That's part of programming or learning about code. Sometimes you have to figure out how to go about the content by yourself. But I hope that was a good learning experience so far. So this has been a start. It has been a journey. Hopefully we'll be able to see you in future workshops, and all the best in your learning journey. See you in the next one.